like waiting for it to start. All right, so a few announcements. One, I totally blitzed, and it's all my fault. I completely forgot about the whole sweatshirt thing. I think I'd even set a meeting that I never showed up to. And I apologize for that insanely. The good news is I did talk to Miss Cosley in the front office. We don't have to do anything with funds or money until second semester. So that's okay. So we don't have to worry about collecting money this month. But I still want to get all of your sweatshirts ordered. And I still need people to submit designs. So if you are any part of that, make sure that you submit something to me. And then once I get that, then we'll figure out what we're going to do. But don't forget, even if you're not part of like the design team, go in and make sure you put your size and whether or not you want your name on it, things like that. I'm going to order so I can still get these all done and to you like after Christmas or winter break. Let's see. Reading guide is up for this week. I'm not giving you one next week. So this is our last reading guide of the semester. The first part is a little bit long, but the second part you're going to notice is really short compared to normal. Slow down my workload? How do I slow it down?
Well, because everything goes so fast.
Yeah. And we're 2 units behind right now, so I am going actually really slow. We should be in the middle of Unit 5 already, and we still have to do Unit 3. I'm slowing down way more than I thought I could. I will say that. This week is going to be a slightly heavy week, and next week I'm going to leave a little bit up to you guys. Well, hopefully, Javea, with the every other day thing, so like I have assignments for you on Monday, like you don't have any assignments on Tuesday. So I'm hoping that helps. Are you asking for like more long-term projects? Like I'll take the feedback, not really. I'll take the feedback because like you've never been a student online before, I've never been a teacher online. Leland, they sent out a schedule. I can try and look for it in my email. I thought I had it with me, but I guess not. Of trying to phase everyone back into school. Juniors are going to get the short end of the stick. They're going to be the last ones that they phase back. It sounds like we're going to go, in January, we're going to go back to 8 periods a day. And the schedule that we had been following. Sorry, I was just reading Javea's comment. So freshmen and seniors would be the first to come back fully. I think the month of January, we're still going to all be e-learners. And then freshmen and seniors come back, then sophomores, and then juniors come back in like April or something like that. That's how they currently have it set to phase. And I'm guessing since they're releasing a vaccine in January, and Colorado is going to be one of the first states to get it, that I don't know if maybe they'll require it, you know, like they require like MMR for you guys or things like that. So I have no idea. I have a little bit, but not much. I'm supposed to find out more this week. And Ashley, I'm totally with you. It is driving the teachers probably just as crazy as it is you guys to keep changing the schedule like this. Like all of us teachers, students need consistency, and it definitely doesn't feel like we're getting it. But I think why they're going to go back to the 8 period a day schedule is because we're going to be in person as well. So it's going to be back to hybrid again. I'm 100% in agreement with you, like 150% in agreement with you. It does make it a lot harder to adjust. Like, you're not the only ones at all. Um, there was talk of maybe going back to a block schedule and a full day, like a normal block schedule would be, um, but that means you would be in like 90 to 100-minute classes. Um, because that
Why
would
so long?
because that's a true block schedule. So I forget, is it like D49, like Vista Ridge or something? I remember when I was applying there and interviewing, I looked at their schedule and they do like even classes on Monday, odd classes on Tuesday, but it's still a full day. So even though you only go to 4 classes, you're still in school for 8 hours. So you tend to have 90-minute blocks per class. Um, And so there is talk of it, but I don't know. They're trying to be cohesive with Harrison High School. Um, so I don't know. And Dante, I have no doubt that that is true. Like, I'm trying to figure out things that work and work better. You guys know I'll always take your input, um, things like that. But it is what it is. I still want to prepare you, especially for those of you that want college credit. I still want to try my best to prepare you for um, like the AP exam so you can get college credit for it. Like it, you know. So that's one thing in the back of my head. Kaden, I totally get that too. I suck at home. That's it. Like all the teachers, all the science teachers, Delhoy, every one of them make fun of me because I would stay every Monday until 9 o'clock at night doing work at school um, because I I can't focus at home. And so now that I'm having to teach at home, I'm even worse. I've had COVID. I've been sick. Like on top of everything else, it's it's crazy. Um, yeah, it is. 8 classes is rough in one day. Um, for both of us too. I definitely prefer the every other day schedule. I would much rather a true block schedule, even if I'm stuck with you guys for 90 minutes. Um, but we're almost done. We have a week and a half left. I'm not even giving you guys a final exam. Um, do you have work that you haven't graded added? The stuff I haven't graded is from last week. And your assessment. I went to put in the grades and I think I wrote them down wrong. So I'm going to go back and double check what I wrote down um, because it didn't look right. I don't know if I wrote something else in that column. Um, your grade is like 90% up to date. So the only thing, especially for you, Naija, the only thing I could see possibly negatively affecting your grade is depending on how good or bad you did on that last test. That's the biggest thing that I haven't put in there yet. Um, so I'd pull it up and show you, but I don't want to like post everyone's grades um, in front of each other. But grades, like I said, for the most part, are updated. I haven't done last week's and like I said, I need to double check the assessment scores that I wrote down because they don't look right. Yeah, it's a test you've already done. Yep.
Why haven't it been inside the grade book yet?
Because I've been sick, man. And it's been rough. Um, let's see. And what else? There was something else. Okay, as far as schedule goes, since that's kind of what we're talking about a little bit, um, we're going to finish the notes today. There is an assignment in the note packet. I'm going to have you guys delete out of your note packet or ignore it. I don't care. It's another HMI thing like the elephants, but we're not going to do that. We are going to crank out most of the notes this week, but like I said, most of them are pretty short. This is a tiny bit of graphing, so the data has already been given to you. You don't even have to come up with your own data, and you'll just throw it in a graph and analyze it. That one is pretty quick. The succession web quest, I'm probably going to edit that before I give it to you guys to be completely completely honest, I think I'm going to shorten it even more. I already shortened it once. I think I'm going to do it again and try and focus it kind of just more on what I want it to for our shortened time period, I guess. The next week, yeah, those aren't assigned. Yeah, because it's Wednesday and Friday. And like I said, I think I'm going to edit the Succession web quest. Next week, where's my calendar? Next week, on Tuesday, we'll just have the 2.0 notes. I'm not even going to do a real assignment that day, but I was going to give you guys an option for your kind of final, if that even makes sense. Hopefully, there it goes. And
We click on this link.
yep. So I would like you guys to click on that link, and I'm going to pull it up on my end as I figure out how to get out of that. There we go. So 2 options for next week. Like I said, just the 2.8 notes, which is really, really, really short because we're going to talk about that a lot more, I think, in Unit 8 or 9, I forget. And then we'll spend Tuesday and Thursday doing one of these 2 options. The first one is watching a documentary. It's about wildfires and creating an FRQ from it. And I'll give a rubric and everything for that. It's a little bit harder, it uses a little bit more brain power, but it's a lot less work. If the other option is a case study, not like the data nuggets ones you've been doing before, but like a slightly more written, thought out one. It won't let you open it. All right. See, reload it and see if that works. Might be because you're not signed in. I hate that part. The case study would be a lot more analysis, and it would be longer. It'd probably be easier, but it'd be more work. So
what would it be about?
Huh?
I said, what would it be about?
I haven't decided yet. I have a whole book of case studies. Do I still have it pulled up? Let's see. So this doesn't look like much, but these are really cool. But these give me, for example, I'll show you what case studies look like. So it gives you like backgrounds, information, and then you have to kind of work through them and analyze them, and then you have like questions, things like that.
Do we need to use the class textbooks for this?
I would say, I mean, you could use them for reference, but I wouldn't say that like they derive from the textbooks or anything. Like if you forgot what eutrophication is, use your textbook and find out. But this is what a case study would look like. So that's going to be your option. Is a case study. This is not the one I would give you, but just so you could see what it would look like. Or you're going to build your own FRQ based on our documentary that we would watch. So you have option 1 and option 2. Where'd it go? Where'd I put it? Did I close out of it? Oh, it was right there. I'm stupid. Okay. So Oh, dang. Okay, Dante. I'm assuming a couple of you will have to leave for PPCC. Don't forget that this is recorded. You can catch it up later if you need to. But I would like you guys all to complete this part. So you, oh, look, 5 of you already had. Thank you. There's your options for your final. It happens. It's okay. Speaking of videos, I want to show something that I'm going to assign to you in AP Classroom as optional. And I would even, next semester, I'll even consider it for extra credit. This survey, KK, the one I put in the chat. But I don't want you guys, when you see a whole bunch of things assigned to you in AP Classroom, I mean, don't forget your DOLs are in there, but with AP Classroom started doing this year is putting out daily videos. And so I was gonna start throwing some of these out to you guys, just if, like, so it was available for you as a refresher. It's not available on YouTube. It's only through this AP Classroom website. But I don't want you guys freaking out that it's required. I think it's a good refresher and a good review, and we'll probably come back to some of these videos before the final exam. But I want them to be available to you for right now, especially because they went in a different order than I did. So I waited till they came out with a couple of minutes. Next semester, yes. Yeah, I'll probably start assigning them for some review. Next week, what day do we end? We end on Thursday. Thursday is our last day. I know. And then you don't get to see my beautiful face for like 2 or 3 weeks. It's gonna be rough, I know. All right. And I think that's it. So I'll look at your responses to the
Miss Pearson,
final. Yeah, what's up?
how long would we be off for?
You are off until, let me pull out my calendar again.
2 weeks.
I think, yeah, I was gonna say, I think I have it that you guys come back the 7th, if this is my updated calendar. So right around then.
Okay.
All right. So go ahead, open up your note packets. It's gonna be a glorious 2 weeks, isn't it, KK? Open up your note packets. We're gonna finish off what we didn't get to. We're gonna talk about limiting agents and stuff in 2.4, and we'll start talking about 2.5 in all caps. That must mean you mean it. All right, 2.4, not to natural disruptions. Come on. All caps means she means it, that it's important. It will be a very important 2 weeks for me. All right, everyone got their note packet open? I'll try and follow along so I don't screw you guys up too much. So I know we got through these. I know I got through the first couple slides probably in a rush, so I'm gonna briefly go through them again. That's what I look like when my camera's off, KK. So remember, range of tolerance is kind of what we're looking at. Like, we can go outside in winter, we can go outside in summer, and we're still gonna survive because these are livable temperatures for us. However, you go out in the Arctic during June, or sorry, yeah, the Antarctic, that's what I was going for. In June, South Pole, you're not gonna last very long because that's gonna be outside of our range of tolerance when it comes to temperature exposure. Okay, So there's an optimal range in which we can function really well. And then there's like the zone of stress, which is like stressed body. You show symptoms usually of something or weakness, lethargicness, anything like that. And then there's the zone of intolerance, which means your body or the species cannot tolerate what is around you. So that was kind of a little bit, we talked about generalists and specialists last week. Did my screen go away? Yes, I am.
Your screen never was up.
It says
Oh, you only had this one up the entire time.
No way. It says I'm sharing. I'm sorry, guys. I'll cancel it and retry it.
Ah, now I see it.
Thank you, guys. I don't know why I did that. Because it said I was sharing my screen.
The wrong one. I think yeah, I think you were sharing the wrong one.
Yeah, that could be. Alright, I guess I need to drink a little bit more of my coffee. Alright, so this is the range of tolerance I was just talking about, your optimal range. It's that bell curve, your zone of stress where you can start to show like symptoms or lethargy, and your zone of intolerance where no species is going to last. Sorry about that. We talked about generalist and specialist species last week and how they would figure into a range of tolerance, what their bell curves would look like. And we did talk about that. I think I remember Leland answering that. So limiting factors. So there's a nice box in your notes that says limiting factors. And we talked a little bit about this when we talked about like the nitrogen cycle, all the biogeochemical cycles. Anyone remember what can happen to water when there is too much nitrogen? Don't all speak at once. No. Well, at least that was honest. Well, you'll see here in a minute because I have a picture. The exact same picture, actually. All right, so when we talk about limiting factors, it's the factor that is most often in short supply. So even if all of your factors are completely optimum, it's the one that's most likely to regulate health and growth. It says just population growth, but health as well. So here's my little fish tank down here, right? And we have his little bubbler going. If any of you have ever killed fish, then you know it's probably could be due to a lack of oxygen. Okay, deal with that. What is going on here? And if he doesn't have his little bubbler going, that means he's not doing the backstroke, but he's dead. He's turned upside, he's belly up, right? So we have a limiting factor here of what? What would be the limiting factor in this poor little fishy's life? What is he missing out on in the second picture?
Oxygen.
Blub blub. Yes. He's missing out on his oxygen. He doesn't have the dissolved oxygen in the water, which is what the bubbles do, in order to get those. So he doesn't get his air bubbles, he doesn't get his oxygen, and suffocates. Poor fish. So when we talk about limiting factors, when it comes to soil, which we have discussed a lot about, I feel bad because I had this all set up ready to go in my classroom and it's obviously still there. Any of you there saw that jar of mud in my classroom? We were going to do some tests on it, but didn't get a chance. So we've talked about nitrogen cycle, we've talked about phosphorus cycle, and potassium. That's what these NPK kits are. They take the initials off the element table. And that way you can go and look at your soil and be like, oh, hey, I'm low on potassium. I need to go find that fertilizer high in potassium, and that will help my plants grow and reproduce. So that's a big limiting factor, is your soil nutrients. Open ocean. Daryl did his rap. I loved his rap on this, on the open ocean when we were doing biomes. Yeah, you guys did something special.
Are we supposed to?
Yeah. Sometimes nitrogen, again, part of our nitrogen cycle with the fish, dissolved oxygen can be a limiting factor. So that's why, I forget, was it KK also did ocean, where it's kind of like some dead zones out there. And that's because they're limited in nutrients and dissolved oxygen, sometimes silica or iron too. Freshwater lakes and rivers. Anyone remember the phosphorus cycle? That was the one we probably talked about the least. It's the only cycle that doesn't go into the air. What does phosphorus usually come from? Daryl, speak up.
Soil? That's like a nutrient in the soil.
So close. It is, but so close. What's there before soil? Isaiah? Anyone? Nope. Before decaying matter. That helps make soil.
An animal.
Water.
A
Nope.
plant. Some living organism.
What's over here?
Mud.
Trees.
Where are you pointing at?
Can you see my? I have
Near some mud.
Leaves. Rocks.
That's
rocks. There you go, KK. Rocks. Phosphorus comes from rocks. Right. Some stream beds or river beds, lakes, don't have a high amount of phosphorus. They don't decay. That is true. They don't decay, but they do weather and erode, and they break down. So that's where it needs that. All right, bye, Dante. Have a good one. All right, bays and estuaries. Anyone remember what estuaries are?
Salt water.
Good. It has to. It's where the salt and the fresh water meet. So estuaries have a lot of organisms, whether it's the plants like you see in here, or fish, anything that survives on low saline water. So it's salty water, but not as strong as it would be out in the ocean. So salt can sometimes, a lack of salt can kill off the plants. All right. And is that the last one? Yeah. Oh. And then the fish tank we already talked about, the dissolved oxygen. Desert plants.
Water.
Yeah, exactly. We're looking specifically at desert plants at the limiting factor of water.
Sunlight.
And then exactly, rainforest plants, that would be sunlight. Floor plants, I guess I should reiterate, because that tree canopy just blocks out all the sun, which we'll talk about when we get to forest fires and why they're good. All right. And what I was referencing earlier, what happens when you get too much nitrogen in a water system?
Whoa.
Yeah.
A lot of algae.
Yep, and so this is why you see a lot of really, really disgusting looking creeks near some farm areas.
From far away, that looks like fresh cut grass.
Right? It does, yeah, it does kind of look like fresh cut grass. I will give you that. Let's see, hold on. I have to fix my settings really quick because apparently, there we go. Yes, don't drown. We'll say there's, this is also what kills off a lot of fish and stuff as well. All right, so I put in another quick question for you, and I'll pull it up on my screen once I figure out which thing I'm using. That's the semester final one. All right, so I gave you a picture up here. There is multiple correct answers. So generally when I give something that has multiple correct answers, I definitely like to focus on the why. So what could be a limiting factor in this glorious picture, Eastern Oregon, and why? So it's 11:01. Hopefully I'll have all of you respond by like 11:03. All right, so take a couple minutes while I get the next PowerPoint pulled up. Do you really love donuts, Leland? Yes, for image. Hopefully you guys can see that. Oh, I was going to show answers. I don't want to show answers. I thought the picture would be a little bit bigger, I'm not going to lie. Maybe. Couple good answers so far. Keep them coming. Okay, you guys like all put them in at the same time. Ah, I can't even click on anything. It's like every time I try, somebody submits something. All right. Let me pull these up and we can see what you guys put. All right. I have names hidden so you can't be too embarrassed. All right. Water precipitation. Water, absolutely. But I asked why. Why is it? What makes you think in that picture? Because there seems to be a drought there. Animals, because this place is so barren and dry, and there seems to be zero animals. You could use animals as far as the living organisms, because, and then the water creates the fact that because there's no water, what animal or plant is going to want to live there. Water, again, limits plant growth, dryness, hard to produce oxygen. Luckily, we have global circulation of oxygen. Like most of the oxygen you breathe actually comes from like microorganisms like algae and all that stuff. So we're good to go. A limiting factor could be water. Judging by the ground, it's very cracked. Do you guys know how the ground ends up like that?
Yeah, it dries out and like contracts or something.
Mm-hmm. So you have, like in Colorado, we got these stupid potholes in the roads, right?
Yep.
So you get the contraction and the rapid heat changes. So like there was one day not too long, was a month or so ago, that we swung from like 20 degrees to 80 degrees in 24 hours. Something so insane. And that honestly makes our potholes worse. So it does kind of something similar with dirt when you have a rapid heating or a rapid drying. So it goes from a very like sudden downpour and then just immediately dries out. You'll get that kind of terrain. So that explains some of that. Don't forget the why, people. Oh, I like this one. I actually hadn't even thought of this one. Water's an ant. All right, whoever puts cinnamon, we're gonna fight. All right. So again, please, please, please focus on your whys. I can look at the picture and see there's no water, so tell me what justification you have for it. And I'll tell you from grading some of your FRQs in the past, that's been your biggest thing. I need more whys out of you. All right. So like I said, we're playing catch up on notes. If you've downloaded these already, I forgot to change the numbers. I just changed it to 2.5 from my PowerPoints from last year. Yes, we're playing catch up. Catch up and mustard. That's actually what one of the English teachers I used to work with, she used to call it mustard day instead of catch up day. If she was giving her students a work day.
That sounds a little odd, though.
It does. It sounded really odd. I needed her to explain it, otherwise I never would have known. All right, so objective, explain how natural disruptions, both short and long term, impact an ecosystem. So that's what we're going to look at today and tomorrow, that you'll kind of be graphing a little bit tomorrow. False alarm. Dante's back. All right. So you can put it in the chat. What are some natural, emphasis on natural, disturbances that can impact an ecosystem? Natural. We're living through one right now. Excess rain, fire. I'm going to go with that was supposed to be drought, not doubt. But, I mean...
That says drought.
A pandemic. Yeah, viral diseases are totally natural disturbances to an ecosystem. Everyone, global warming is not the answer to everything, but there are things that do cause it. See some of y'all typing still. Tsunamis. Ooh, I like it. Daryl reached back to his Earth Science days. He's been an awesome science teacher. Volcanoes. Beautiful, Ashley. Earthquakes, too, along with the volcanoes and tsunamis. So, yep, whole bunch. So hopefully you have some of those that you wrote down in the chat, written in your packet. Balance between species. So that is a result of a natural disruption. But I feel like you're going with like humans on that one, human impact. And we have definitely outbalanced every other species for sure. All right. And then there's two words that we're going to talk about. They often get intermingled with each other. And I think it may be because they both start with similar letters. The first one is resistance. Just like it kind of would seem in a normal everyday term, it's to remain unchanged. Leland resisted my efforts to have him stop talking about donuts, right? And he does it every day still. So even when I'm like, on task, Leland, he's resisting me. So it's the ability to remain unchanged when being subjected to that disturbance. So like right now, depending on how big or bad this fire was, maybe the fish in the creek aren't being really affected by this. If it was a bigger fire, they definitely would be, from the silt and the sand that would come down in. But we're talking about resistance, so this won't bother them too much. The second word is resilience. All right, the ability and rate of an ecosystem to recover from a disturbance and return to its pre-disturbed state. That was a real picture of a forest fire, yes. And if you choose the documentary route for your final to write an F or a Q on, then you will definitely be a lot more familiar with forest fires. So we could even think you guys are old enough to have experienced Waldo Canyon, right? So Waldo Canyon went through a huge, huge fire. It's slowly and coming back. I know I was, over the summer, I went out to, there's that reservoir where you can go fishing. I went with Mr. Gallegos and Mr. T. I forget what it's called, but there's a reservoir that's at the edge of the Waldo Canyon fire. You found Waldo in a canyon? That's good. I have some what is it? Instead of find Waldo, it's find, oh my God, why am I, Baby Yoda. And it's all in Christmas stuff because it's Grinch. So green Baby Yoda, green Grinch. Anyways, so you're looking at how fast it can return to that pre-disturbed state. In most cases, it takes years to go back to it. But some ecosystems, even ours here in Colorado, require these disturbances in order to function and in order to build diversity. All right. So this is a really funny looking graph, and it's really overwhelming, I think, at first glance. But just looking at, let's say, the x-axis, yeah, it is a little much, but it's better, I think, than having to read a paragraph about this or two. We have desirable condition to undesirable and kind of an in the middle. And then we have a intervention and a cost of intervention. So intervention would be like something helping it out. And then you have decline and recovery, arrows going in opposite directions. So something happens and it brings down your ecosystem. It's still able to recover, but if it hits this threshold, this boundary, and it's different for every ecosystem, it will plummet the ecosystem until it's either able to recover or it continues to decline. Okay, and it can keep doing that. Kind of looks like a staircase, but the reason the graph kind of goes up here is because you have to push that ecosystem to that limit, to that threshold. So just a little bit of a disturbance and it'll bounce back. But once you push it to that threshold, then it drops.
Does it always work like this? And will it always look like this?
Theoretically, yes. In real life, no. So you'll have things that you could place into this graph and examples and stuff like that. It just, with every ecosystem being different, you're dealing with hundreds of variables. It's not going to be this perfectly pretty graph, but it'll be close. Kind of like a predator-prey. If the foxes run out of rabbits to eat, their population drops, and so it kind of mimics the rabbits behind it. Kind of. This is almost like a predator-prey graph. Resistant versus resilient. So remember, resistance is I'm not going to change, no way, and resilient is I can put up with it. How functioning and how good and healthy an ecosystem is depends on whether it's resistant or resilient. So in a resistant one, it can put up with a disturbance, but it might get hit with another one or a harder one, and the whole thing just depletes and it dies. All right, the whole ecosystem is diminished. No, don't draw this one. It'll be the next slide, I think. And then a resilient one, it gets hit by the disturbance and then it bounces back. It gets hit by the disturbance and it bounces back. And so the resilient ecosystem is better to bounce back. You're going to have more of your genetic diversity, things like that, whether it's for good or for bad. You know, this is how super bugs get created. But yeah, don't draw those. What you are going to draw is this. And I realize this is a very blurry graph, but it was unfortunately the best one I could find, and I'm super sorry for that. This is called the intermediate disturbance hypothesis. And if you've ever heard the term everything in moderation, this is kind of what this graph is talking about. So this is species diversity. So down here would be a low amount, up here would be a high amount of diversity. This is the one you draw. If you have a lot of disturbances and they're super frequent, you're going to have low diversity because you're constantly like killing things in that ecosystem. But if you have very infrequent ones, you're also going to have a low diversity. So at either end of that spectrum of how often that ecosystem gets disturbed, you're going to have low diversity. When you get it just occasionally in between, you're going to have the higher diversity. All right, large disturbances versus small and soon and long after. So everything in moderation. I personally, especially because I was just teaching in earth science, the Goldilocks principle, this is the Goldilocks. Too little or too big won't work. It's got to be just right, got to be in the middle.
What's the measurement or variable for the bottom one right here?
The bottom one is how often or how harsh a
Climate harshness.
Mm-hmm.
Wait, climate or just ecosystem?
Ecosystem.
Okay, ecosystem harshness.
Yeah, we're looking at all the different variables combined. In your packets where it says historical changes in climate, CHHMI computer activity worksheet, I'm not going to give that to you guys, so you can delete that or ignore it, doesn't matter. I'm not going to make you guys do that.
Every part of it?
Just the A part, because the next part is still part of the notes.
Okay.
All you really need to know for that is historically climates have changed. That's why we can find like sea fossils in Colorado Springs. You have dinosaurs, especially over on the western slope. You can find tropical plants underneath the Arctic Circle, up north at the North Pole. So things change. That's really what that tells you. Is that an unhappy dinosaur with a cold sore? It's the wrong kind of sore. So
A-R, not S-O-R-E.
This hypothesis is how often does the ecosystem get disturbed in order to create high diversity of species within that ecosystem. And by intermediate disturbance, it means like how often and how harsh they are. So you don't want them every day, but you don't want them 100 years apart. You want it somewhere in the middle. Same with like a whole lot of disturbances that don't do anything versus like insane ones like the coast of California just drops into the Pacific Ocean. We're going to lose all of our species diversity. So that's what it's talking about. It's that in the middle is the best option for high species diversity. So officially, it's the intermediate disturbance hypothesis states that, and let me see, I will, oops. Type it. Let me get all this paper out of my way. So that's what it is. So we need disturbances in order to get it high diversity, but you don't want them too often or not at all, too infrequent. Pull my paper back. All right. I don't understand, like, the monetary system. I don't know.
No, because you said there has to be struggle, but not be too severe.
Oh, okay. Yeah. So an intertidal system is an example. This is where you're going to find your most diverse water habitats. Intertidal is also your coral areas too. It's where the tides kind of come in and out, where water can seep or sunlight can seep down through the water. Things can still grow. This is where you're going to find your high diversity.
Where's this?
That was just an example.
No, I mean,
like I said, I'm not going to have you guys do the interactive. We've got 2 minutes left, so we'll probably stop after this slide. So historical changes in sea level. You guys hear a whole lot in the news, especially about like climate change and sea level rising, and Florida's not going to be there anymore, and all this other stuff. Along with everything from Pangea to now, we have also had freezing and melting ice caps, which I think is one of the things that the biointeractive shows. But I mean, down to where we are now is where the ice cap used to go to during an ice age. So it went down to like Texas. That's why also in northern regions, a lot of your lakes tend to run north and south, and they're really long because that they were carved by receding ice. So you have your sea level change up top. You have carbon dioxide levels based off of ice cores down below. I have no idea. I could see there being dry ice in the Antarctic, to be honest. All right, so we'll start here Wednesday and then crash through the adaptions part. Okay? All right, we'll start here on Wednesday.
Okay.
So have a good rest of the day. I'll try not to stress you out too much, and I'll let you know Wednesday what your final's going to look like.
Okay. Bye, Miss. Bye, everybody. I'll see you all on Wednesday.